The question we are solving now belongs to test series 5. It is of network theory subject. In specific, it belongs to sinusoidal steady state analysis. As per the question, there is a AC circuit given as shown in the figure. The AC circuit has an excitation of Vi is equal to Vm sin omega t. It means that circuit is operating at an angular frequency of omega radians per second. There is a resistor R1 which is in series with the voltage source. This combination is connected in series with a parallel combination of resistor, inductor and capacitor as shown. The relevant values of these elements are L, C and R2. Please note that this is a common data question. We need to find the frequency at which the impedance as seen from the source is minimum. We need to find the omega naught such that the impedance as seen from the source is minimum. Now let us find out the impedance as seen from the source, which can be written as Zs is equal to R1 plus j omega L connected in parallel with 1 by j omega C connected in parallel with R2. This upon simplification can be written as R1 plus R2 into L by C divided by L by C plus JR2 multiplied by omega L minus 1 by omega C. So we have to find the frequency at which the magnitude of the impedance is minimum. For the magnitude of the impedance to be minimum, the quantity marked should have the maximum value as it is the only quantity that is dependent on omega. Now let us define B. Let us define B is equal to the magnitude of the quantity marked, that is L by C whole square plus R2 square multiplied by omega L minus 1 by omega C whole square. We know that for this quantity to be maximum, dB by d omega should be equal to 0, and upon simplification we see that the corresponding value of omega, that is omega naught, is 1 by root LC. So this value of omega naught corresponds to a local minima or a local maxima. Now we need to find what this value of omega naught correspond to. So for that, let us find out d square b by d omega square, and we see that it turns out to be less than 0 at omega naught. As dB by d omega is equal to 0 for omega naught and d square b by d omega square is less than 0 at omega naught equal to 1 by root LC corresponds to max of b of omega. So which is the magnitude of the denominator quantity. So as b of omega has maximum magnitude at omega naught equal to 1 by root LC, Zs will be minimum, or the magnitude of Zs will be minimum at omega naught. So from this we see that the frequency at which the impedance as seen from the magnitude of the impedance as seen from the source is minimum when omega naught equal to 1 by root LC. Hence the correct option which represents this frequency is A.